I always need to use a table when I'm solving rational inequalities, and quadratic ones for that matter. So here is my filled out table. Now I can just read off which of these regions contains x values that make this fraction, or this rational expression, negative. So that's just this first region, which is x is less than 2, and the second region, x is greater than 3. Since on a number line, these two regions do not overlap, we have to use an or, since no value of x can fall inside both regions. So our solution is x is less than 2 or x is greater than 3. Let's take a second to think about how we could visualize this inequality using graphs. So here I've plotted two equations. I've plotted y equals negative 16x plus 48 over the quantity 3x minus 6. And the purple line is just the line y equals 0, the x-axis. We want to know, according to our inequality, when this line, the pink one, lies underneath the purple one. We want to know when the y values of this curve drop below this curve. So we can see that that's every part. That's going to happen for all x values, except for those in the very small portion of the curve that's up here. We can see that this matches the solution we came up with. This curve lies below this one, anywhere beyond this point, where x is equal to 3, and anywhere in this part of the graph. This line right here, that represents the disconnect between these two portions of the pink graph, goes straight through the point 2, 0. And in fact, this is the line x equals 2. We can see that the entire part of the pink graph that's to the left of this, or that has x values less than 2, is underneath the purple curve. So this fits what we found. Awesome.